All right, question 6. Right, in the diagram, OABCDEFG is a cuboid in which OA is 2 units. Basically, this much is going to be 2I. Right, then OC is 4 units. OC, where is OC? OC is 4 units, basically 4J. 4J. Right, so in that case, OG is 2 units. OG upstairs, so it's going to be 2K. 2K, since the unit vector is K in that direction, and unit vector in this direction is actually J. Right, so unit vector in OA direction is I. Right, so that's why I'm writing in terms of I, J, and K. Great, so next you have unit vectors I, J, K are parallel to OA, OC, and OG. Right, next you have the point M is the midpoint of DF. Where's DF? Right, so basically the ratio is 1:1, and M is the midpoint of DF. Great, so if that's the case, the ratio is 1:1, and the point N on AB is such that N on AB, where is it? N on AB is such that the ratio is AN is 3NB. AN is 3NB. Basically, this is 3:1. 3 parts of NB is inside AN. Great. So if we know that, they're asking you to express OM in terms of I, J, and K. Then we will be finding MN. So first of all, let's find out OM. Where is OM? OM is basically from this corner to upstairs. Right, so how do we go over there? The first job is go from O to A, and then from A we will go to N. We can go to N, and then from N we can go to, I'll clear it out. So we're going from O to A, then from A we're going to this point, which is 3/4 of AB, or we can say directly 3J, since the vector in this direction is J. So we can say 2I plus 3J. So we have reached which point? We have reached this point. Sorry, not this point. The point N. So we have reached 3J, which is this point N. From N, what do? We reach this point. The point directly below M. The point directly below M. So how do we go there? It's basically very simple. It's going to be back to this direction, which is 1 unit over here, and you're going to subtract -I, and then go forward by 1I. Great, so now you're directly below M. So then what you do is go up by 2K. If that is all too complicated, I'll write in terms of the unit vectors. So first of all, you're coming down by 2 units from O to A, then you're going to J, 2J, which is this position, and I basically went to N and then came back to this position. I don't know why I did that. So yeah, so you can directly go to this position, which is 2, which is the midpoint, basically directly below M. So from this 2J, you can go to the midpoint, which is 1I, and Y minus, because this is AO direction. This direction is positive and this direction is negative. Great, so -I plus 2K. Why? Because you're going upstairs. Right, so plus 2K. You add all of these up and you're going to be getting I plus 2J plus 2K. Right, that is your OM vector. Great, so now if we want to find out MN, you're going to go from M to where? Oh, where is N? Right, over here. So you're going to go from M to N. What can you do? There are a few things to do. You can use MO directly from this point to over here. You figured out OM, which is this. So MO is the direct opposite of it. So -I minus 2 minus 2K. This is your OM, right? So if you know that, Next, after going to this O, you can come down by 2i and then go right by 3j. So 2i from O to A, and then from A to N 3j. You simplify all of that and you're going to get this, which is your mn. Right, so we have answered question A. Right, after question A, what do we have? We have question B. You find a vector equation for the line through M and N. Vector equation for line through M and N. So what is M and N? So basically, you start from, let's say, any position M. I'm going to be taking M. You could take N as well, doesn't matter. So I'm going to be taking M, which is where? Which is over here. So they want to know the line, this line, the vector equation for this line Mn. So I'm starting from M, and the vector for Mn is basically given over here. You plug that vector in over here, you introduce a magnitude, you start from any point you like, and then you have a vector equation. You just put the values in and you have a vector equation. Nice. After you do that, we have question C. What is it asking you? Show that the length of the perpendicular from O to line M and N is root over 53 by 6. So basically, if O is over here and Mn is this line, it reaches Mn perpendicularly. So there is a theta of 90. Instantly, they are telling you there is a theta of 90. You should go to the dot product. You should directly go to the dot product, since they've given you the theta, which is 90. And if the theta is 90, cos 90 is 0. So you can directly go to the dot product. Nice. Now what do you do? You basically have the equation, which is for OP, let's say. For OP, you're going to make the equation y. Basically, P is lying on the Mn line. Do we know the equation for Mn? Yes, we do. This is your equation for the Mn line. And as explained before, if P is lying on Mn for a certain value of lambda, it's going to give you the coordinates for OP. Definitely. So you can write OP is equals to the starting point plus lambda times the vector Mn. Next, what do? You write the x, y, and z vectors together. Great. So you also know Mn, which is 1, 1, 2, this, and you also know OP. Great. Next, you directly find the dot product and equate to 0. 1 plus lambda times 1 plus 2 plus lambda times 1 plus 2 minus lambda times minus 2, and you're going to be getting 0. You make lambda the subject and you're going to be getting lambda is equals to 1 by 6. So that is your value for lambda. And since you were supposed to find out OP, you need OP to find out the distance OP. So you can directly find the value of OP, the coordinates of OP, by plugging in lambda where? Over here. Plug in the lambda values and you'll be getting the coordinates for OP: 7 by 6, 13 by 6, and 5 by 3. So that is your value for OP. After you plug that in, you can find out the magnitude, the distance. How? Square this, add, square this, add, and square this and add under a root. So you're basically squaring 7 by 6, then adding the square of 13 by 6, then adding the square of 5 by 3, and under a root to get the distance OP. This is your distance. Great. So that is your question 6. They wanted your distance from O to P, the foot of the perpendicular, and you received the distance OP, the magnitude. Great. Now we can move on to question 7. Okay. Question 7, what is telling you? That lines L and the lines L and M have vector equations. R is equals to minus I plus 3j plus 4k plus lambda times 2i minus j minus k, and R is equals to 5i plus 4j plus 3k plus blah blah blah. Okay, so respectively where A and B are constants. Given that L and M intersect, show that 2b minus A is 4. Okay, so they've already given you an information, which is this line and this line. Basically these two vector equations are going to be intersecting, meaning all of their coordinates are going to be equal at a certain point, right? So if that is the case, you know the equation for L, which is -1, I'm just writing the coordinates, -1 plus 2i minus 1 plus 2i, then 3j plus minus j lambda minus j lambda, and then plus 4 minus k lambda, minus 1 lambda, minus 1 lambda, 4 minus 1 lambda. For this case you have 5 plus a mu, then you have 4 plus b mu, then you have 3 plus mu, right? So these are your coordinates for each of L and M. For both the lines you have the x, y and z coordinates. Now since they've told you that they are going to be intersecting, it's very simple. You're going to equate all of these coordinates together. You're going to be equating all of these coordinates together, and you will be finding that at a certain point they're going to be intersecting. So what are the equations? You equate x, y and z together. This is one, this is one, and this is another one. I have simplified the third equation into this. I've taken minus common and introduced all of them as positive, right? So now you have 3 equations to deal with. What do you do with them? You simultaneously solve them and try to prove this. 2b minus a is equals to 4. That is your final objective. Nice. So if that is the case, let's do one by one and plug in equation 3, this one, into equation 1. Alright, so 1 minus mu, which is the value for lambda, and we plug that in and we get mu is equals to 4 by minus 2 minus a. So now you have another equation for mu. You plug the mu in where? You're going to plug it in second equation, and you're going to plug in the value expression for lambda as well. This is your expression for lambda, and you're going to plug this in over here as well, so that both mu and lambda are going to be omitted from the equation. So you do that, plug in value expression for lambda, plug in expression for mu. You do both of them, and now you have an expression consisting of only mu, while you have the constant a and b as well. You just want the expression to be in terms of b and a. You don't want the mu. So again, you input the expression for mu to remove it, and the final equation that you get is in terms of b and a only. So you have omitted all the symbols for both lambda and mu. So the final equation is only going to have the constants b and a. There are several ways to do this. I've just done it in a specific way. You can use the equations in any order as you please, right? So the main point is getting to this equation. If you have a shortcut, you can use it, no problem. You just have to show that 2b minus a is equals to 4. That is the gist, right? So a is done. We have shown that 2b minus a is 4. Next we can go to b, which is telling you, given also that L and M are perpendicular, find the values of a and b. They've told you they're perpendicular, so directly where do you go? Dot product, right? So the dot product is going to be what? 0. Dot product is 0, so you write the equations again. And for this one, it is in terms of a and b, which is this. This is one vector and this is another vector, and the dot product of both of these vectors are what? 0. 2 minus 1 minus 1. Where is it? 2 minus 1 minus 1. 2 minus 1 minus 1. And a, b, and 1. A, b, and 1. Where is a, b, and 1? This is a, b, and 1. And the dot product of both of these are going to be 0. Great. So what do we do now? We are basically going to again find the scalar product and equate it to 0. That is one of our equation in terms of a and b. The other equation is in terms of a and b that is already given to us. So very simple, simultaneously solve both of these and you're going to be getting the expression, a value for b and a. Just plug the values in, simultaneously solve them, and you're going to be getting the values for a and b. Nice. So if that is the case, now you have b and a. What are they asking next? For c, they're asking you, when a and b have these values, find the position vector of the point of intersection of L and M. So do you know the expression for L and M? Yes, you do. This is the expression for mu. This is the expression for lambda. Okay, that is the expression for mu, that is the expression for lambda. You plug in the value for a, you plug in the value for mu. Where is mu? And then you get the values for mu and you get the value for lambda after you plug in the values of b and a. Nice. Only b though, only a. You don't need b. Great. So after you do that, you get back to the main equation. You can use any equation, be it L, which is in terms of mu. I guess in terms of mu, right? Yeah, it is in terms of mu. You can use any of the equation and plug in either mu or lambda, and you're going to be getting the same coordinate, this. So you're going to plug in lambda, and you're going to be getting what? The coordinate where they intersect. Right, the coordinate where they intersect. So after plugging in all the values, you're going to be getting the coordinate where they intersect. You can use another equation as well, but in that case you will be plugging in the mu value. You can use either, you're going to be getting the right answer. Alright, question A. What are they telling you? With respect to the origin O, the point A has position vector given by OA is I plus 5j plus 6k. Line L has vector equation R is equals to 4i plus k plus lambda times minus 1 I plus 2j plus 3k. Great. So they've given you what? They've given you a line equation L, the vector equation. And they've already given you another vector, which is another position, which is A with respect to the origin. So what are they telling you in A? Find in degrees the acute angle between the direction of OA and L. Again, the moment they tell you find the angle, you directly go to the dot product equation. So what is the dot product equation? A times B, or in this case A times L, the equation, and the magnitudes of the vector times the cos theta. Right, so you find out the scalar product of the vectors. In this case, the scalar product is going to be in this case, this is the vector, and for this A, this is the vector. So 1 5 6 1 5 6, and in this case minus 1 2 3 minus 1 2 3. Great. You find the scalar product, minus 1 times 1 minus 1 plus 5 times 2 10 plus 6 times 3 18 is equals to root of 62, basically the mod of this. So 1 plus 25 plus 36, and mod of this, which is 1 plus 4 plus 9 root over. Right, so you multiply both of them, you have cos theta, you make cos theta the subject, you get, theta is equals to 23.6, Great, that is your theta. P, find the position vector of the foot of the perpendicular from A to L. From A to L. So basically they're asking you to find out position vector P where A connects to L while making a 90 degrees. So from A to L they connect and intersect at P. They're asking you to find out the coordinate P. They're asking you to find out the coordinate P where they intersect. Okay, so you know OA, which is what, 156. Next, you know, what do you know? You do know the equation for L, which is this line equation. Oh no, yeah, this line equation, which is, in this case they didn't write J, so 0J 401. Yeah, starts from 401. The vector is -1. Oops, -1 plus 2, -1 plus 2, -1 plus 2, and add 3. This is your line equation. This one. And the vector equation, basically you need to find out AP as well. Now where does OP lie though? Again, you use the same theory. Since OP lies on the line of L, you can write OP is equals to this equation. So you can directly write OP is equals to 4 minus lambda, 0 plus 2 lambda, and 1 plus 3 lambda. How are you being able to write this? Since for a certain value of lambda, you are going to get the coordinate OP. So for if the lambda is exactly equal to 2, in this case, you're going to get the coordinate of OP. This is why we can formulate this equation. Right, so if you know that, now you know OP. Directly from that, you can form an equation for, let's say, AP, because you need the AP to find out what do you need? You need the position vector. Right, so you need to plug in OP over here. Since the dot product is actually 0, the degree, so AP is going to help you to find the dot product, and then you can revert back to this equation to find OP. So if you got nothing out of that, let's go step by step. Basically, let's find AP, which is this line. So let's find AP, which is AO plus OP. Do you know AO? Yes, you do. Do you know OP? Sort of, in terms of lambda. So AO is basically reverse of OA. So you know OA over here. So yeah, add the minus sign and you get AO. Add, what is it? OP. Add OP, and you're going to be getting this expression for AP vector. Great. So the dot product of AP line and the line L is going to give you 0. So multiply, get the scalar product of both of them, and it's going to be equal to 0. So I've done it, and lambda comes out to be 2. So if you get back to this equation now, since you know the lambda at which OP it lies on this line L, so you can plug in the values for lambda, which is 2, and you will be getting the coordinate for P. So now you have the coordinate OP, the position vector P, 2, 4, 7. Great. Now what do we have? C, find the position vector of the reflection of A in L. It's fairly easy. So take this diagram, let's do it again. So A lies over here, and they're asking you that A is reflected on the line L, and it's going to be reflected over here. So what is going to be the position vector of A star, the reflection of A? Find the position vector, right? So the position vector, it's basically look, so you know OA, you also know OP, you also know OP, you also know AP, at least in terms of lambda above over here. Where is AP? This is AP. So you do already know AP, right? So since you have figured out lambda, which is lambda is equals to 2, you can plug in the value for lambda and you'll get AP. Why do we need all of these? Basically, you want to find out OA prime, basically the reflection of A, the position vector of reflection of A. So how do you go to the reflection of A? You're going to travel to OA, take a transit and go to twice AP. You know the AP and you know this is a reflection, so this distance is equal to this distance. So twice AP, 2 times the vector AP. What is vector AP? This. So 2 times this vector and add it up and you're going to be getting 338. This is your OA prime position vector. Great. So now you know the answer for C. Next up we have question 9. What is this, man? Okay, question 9. In the diagram OABCD is a solid figure in which OA is equals to OB. OA is equals to what? OB is 4 units. Okay. Yeah, 4 units. Good. So next, and OD is equals to 3 units. Okay, the K is 3 units. The edge OD, what is OD? OD is vertical. Okay, DC is parallel to OB and DC is 1 unit, 1J. This is parallel to this direction, so J. Okay, good. So next they're telling you the base OAB, this triangle base, is horizontal and angle AOB is 90 degrees. Unit vectors I, J, K are parallel to OA, OB and OD. The midpoint AB is M. Good. And the point N on BC, where is BC? Yeah, BC over here, is such that CN is 2NB. CN is 2NB. Right. It's in the ratio 2:1. Good. So A express vectors MD and ON in terms of I, J, K. Very simple. MD. So you're going from M to D, up above over there. So you're going to be traveling from M to A first, M to A. So M to A, you can represent it as half of minus AB. Why? Because you're traveling from the B direction to the A direction. And you know AB. You know AB. I mean, you don't know, you're going to be figuring out. So it is basically minus half AB. After you go to A, you're going to go to O, which is minus 4i, because this direction is positive 4i, this direction is minus 4i. And then you go above by 3k. So let's break AB down. Let's break AB down into minus 4i plus 4j. Minus 4i plus 4j. Why? Because from A to B, the vector is minus 4i, since opposite direction, then plus 4j. So you have this and you simplify it, and this is your MD. This is your MD. Good. Next you have ON. What is ON? You start from where? O to N. You can directly go to D, then ON. Okay. So what you can do is you can go above by 3k to D, and then you can travel J from D to C, and then after that you can go 2/3 the distance of CB. So what is the distance CB? You're going to break it down over here. So the first step, we write it as this: 3k plus j plus 2/3 of CB, 2/3 of this distance. And then let's break CB down, right? Let's break CB down. How do we do that? We're going to go again backwards, minus j, go down minus 3k, and then to B, which is positive 4j. positive 4j. Positive 4j. Great. So simplify all of this, and you're going to be getting k plus 3j. You're going to be getting k plus 3j. Okay. So now you have the vector for ON. Nice. So you have vector for ON. Now what do? We go to question B. Which is calculate the angle in decrease between direction MD and ON. The moment they ask you for angles, what do? You directly go to the equation, the dot product equation. Right. So the dot product, both MD and ON, both the vectors. You plug in the vectors, very simple, and you plug in the modulus of the vectors, basically their distance, MD and ON. You plug them in, which is basically the root of square of all of those values. Great. And you multiply cos theta, make cos theta the subject and cos inverse, and you're going to be getting 103.3. This is your theta. Great. So that is how you solve B. Now the interesting part is C, I guess. Show that the length of the perpendicular from M to ON, right, M to ON is root over 22 by 5. So basically they have ON, and this is this is M, and it's going to make a perpendicular with ON at P, where it intersects. So basically 90 degrees, again, very simple. What do you know? The dot product is 0. Great. So for OP, what is the vector equation? For OP, the vector equation is simply starting from origin to 0, 3, 1, which is the vector for n, right? So the vector for n is 0, 3 and 1, and starting from origin O, the OP is going to be lying anywhere in this line. So you can say for a certain magnitude lambda, you will be getting the vector for OP, So for a certain magnitude lambda, you get OP, which lies on the line ON or vector N, right? So now you have the vector for OP in terms of lambda, right? So let's write OP and break it down, because the main objective is to get to MP, because they ask for most likely, right, the distance, right? Yeah, the distance. So you need MP. So let's break OP down into OM and MP. So let's break OP down. We have OP is given by OM plus MP. Great. So make MP the subject, and you have OP, which is in terms of lambda, and you have OM, which was already given above. If not, it's basically going from the distance from O to M. You can find it out again from O to M, 4i plus half of BA. So 4i plus half of BA, which is going to be 4i minus half of AB. What is AB? We've already figured that out somewhere, I guess over here. Yeah. So you plug that in, and you have OM. This entire thing is your OM. Right. So now you have MP in terms of lambda. Right. You have MP in terms of lambda. How do you remove the lambda? Very simple. The dot product is 0. The dot product is actually 0. So you take this, which is basically this, and multiply it with the known vector, which is 0, 3, 1. This is the known vector of the line, and this is the vector which is known in terms of lambda, which is basically the vector for MP. You take the scalar product of both of these and equate to 0, and then you find lambda. After finding lambda, you plug the lambda in where? In this vector. In where did it go? Right, in this vector. So minus 2, 3 times 3 by 5 minus 5, and then again 3 by 5. So this is your MP. Then how do you find the length? You take the modulus. So it's going to be 4 plus 1 by 25 plus, what is it, 9 by 25, and this gives you 22 by 5. Great. That is how you solve for question 9. Alright, question 10. Relative to origin O, the position vectors for A, B and C are given. Great. So we use the scalar product for and find the cosine of angle BAC. So to find BAC, we have to find the vector AB and AC. Very simple. The breakdown of the vectors are given. So AB is OB minus OA and AC is OC minus OA. Great. So you have the vectors AB and the vector AC. Great. Now use the dot product equation. You put in the value, the vector for AB, put in the value, vector for AC, and then find the modulus, the length, the distance for AB and AC. And for AB you see 2 square plus 2 square plus 1, which is root 9, and for AC it is 4 square plus 3 square, which is going to give you 25. So that is your modulus. Great. So you may cos theta the subject. They want to know the cosine of angle BAC, this angle. So now you have cos theta is 1 by 3. So you have it. So for question B, they wanted to know the area of the triangle. So you know the cos. So you can write the adjacent, you can write the hypotenuse, and you can use Pythagoras theorem to find the height, which is basically 3 square minus 1, and it's going to give you 2 root 2. Great. So now you can find out sine theta using this. So basically for the area you have half AB sine theta. Where is A and B? Basically this AB distance is root 9, so it is 3, so that is A. And for AC distance, that is root 25, so 5, so that is your B. 3 times 5 times sine theta. Sine theta is basically opposite 2 root 2 by hypotenuse, which is 3. That is your sine theta value. Plug everything in and you have the area, which is 5 root 2. That is your question 10. Good.